Now that we know a little bit about what JHipster is, let's take a look at the problem that it solves. In this lesson, I want to talk about what it takes to build traditional Java web applications. For example, let's pretend our company has asked us to build a very simple blog application with a few specific business requirements. This is a list of features our application should include. It should have a nice user interface and a very good user experience. If we're putting this application on the web, it should be responsive. It should respond to different form factors. So if we view this on a tablet or a phone, it shouldn't look all messed up. Single page applications are all the rage these days, so we should probably do that as well. We may want to include I18N or internationalization so that we can speak to a broader audience. We probably want an MVC framework in there. We probably don't want to build one of our own from the ground up because that would be pretty expensive on our part. We need to have security. We need a secure app, and we need ways to authenticate users for different roles. We may want to have a social login so that users or administrators can log in via Facebook or Twitter. We want to have distributed cache, so when we scale this application, we could put it on multiple servers here and have that cache distributed across those servers. We also want search capabilities, so whether it's searching blog posts or users, just searching across different domain objects. We also want a build system. We also want production optimization, so when we publish this particular app to our production servers, we are optimized and we are fast. We need to be speedy in production. We also want some versioning on our SQL databases. We want automated tests, we want performance tests, and we want some behavior-driven development tests. We also want some metrics to tell us what is going on in our application at any time. We want to be able to have user management, so when we create our new users, we have the ability to edit them and grant specific roles to them. And we also want auditing and login. So basically when people log in and we can audit that, we know who's logging in and when, and we want audits on different things like when posts are created or when comments are created. We basically have an audit trail on everything. So that was a list of all the requirements that we're going to need. So what's going to be required to implement all of those requirements? So I know you're not going to remember every little circle from the last slide, so I'm going to kind of tell you which one they were as we start to go through them. So for the UI and UX, we're talking about HTML5 and CSS3. So we want a modern, sleek web application. For responsive, we're going to use Bootstrap, and that's going to allow us again to create these nice responsive applications that will respond to different form factors like tablets and phones. Angular.js is a great framework for the front end and allows us to build our single page applications. There's also a plugin for Angular called AngularJS Translation, which will allow us to do our internationalization. For the MVC framework, we're going to be using Spring Boot. If you know me at all, I'm a huge fan of Spring Boot, and it's going to simplify a lot of our Spring development. We're going to use Spring Security. It plugs in nicely to Spring Boot, and it is a great security framework. Security is really hard, and this is not something you want to do on your own. So I'm glad we get Spring Security right out of the box. With Spring Social, we have the ability to have social logins. So again, if somebody wants to log in via Twitter or Facebook, we can use Spring Social for that. We got Hazelcast for our distributed cache. We have Elasticsearch for our capabilities to search across domain objects. We have Gradle for our build system, but you can also use Maven if that's what you're comfortable with. As far as production optimizations go, we're going to have gzip, cache, and minify across our different assets right out of the box. This is something that you probably don't want to do on your own, and it's one less thing you have to worry about. Database versioning with liquid base. So this is going to become very important, and you'll see as we start to build out some applications. And then as far as testing goes, we have Karma. Karma is basically a JavaScript test runner, and the main goal for Karma is to bring a productive testing environment to developers. Gatling we use for basically it's a highly capable load testing tool, so we can load test our applications there. And on the testing front, we also have behavior-driven development, and Cucumber merges specifications and test documentation into basically one cohesive whole. So from the metric standpoint, we get Spring Actuator out of the box, and this gives us some really nice endpoints that give us a peek into our application as to what's going on. With Spring, we get some user management out of the box, and we also have the auditing right out of the box. So that's kind of what was all of those features that we had and what was kind of required to make those features happen. So now that we know what it's going to take to build our simple blog application that our company's asked us to build, how about a timetable to finish that work? So let's talk about the task and how long we think it's going to take. Again, these are just high estimates. It's not a specific science here. So let's say we build out our entire client-side application by setting up angular.js and then going through and creating, the UI for everything and all the different screens that we're going to have on both the front end and the administration side. We're probably looking at about 6-7 days. On the server side, we're going to set up Spring Boot. We're going to do a bunch of things to kind of configure Spring Boot, and we're thinking on the back end to kind of wrap everything up. That's going to be about 10 days. We'll need a day to kind of write out our entities. We'll need 1 day for those very few specific business logic requirements that we had. Profiles will allow us, half a day here. And basically we're going to set this up for development, testing, and production so that we have different things that we need to do in development and different settings and beans that we may configure for production. And maybe we're using WebSockets. Maybe we want to get some more real data time transactions and notifications there, so we could use WebSockets for that. We may want to go ahead and set up Swagger so we get some API documentation on our RESTful endpoints. And we may want some productivity from a developer standpoint. We could use a tool called Browser Sync, and it gives us some really cool real-time workflow upgrades for us. So that's kind of just the overall, these aren't specific numbers, but let's just say 21 days total to build our pretty simple application. So we know that meetings and other things come up during a work week. So we're just kind of basing this off a traditional work week. So I'm going to say this is going to be a 4 to 5 week project and 5 weeks of work. And again, we're talking about a very simple application here. What happens when we get into building something more complex like an e-commerce solution? So that's what it's going to take to build our simple application. As you can see where this is going, one of these things that we talked about here is the business logic, and that's really all we care about in most situations. What is specific to the application that we're building? The foundation, the boilerplate code, shouldn't be something that we're continually writing over and over again. So now that we know what it takes to do that, let's take a look at how we can kind of solve this problem, and we'll do so in the next lesson.